Well, I'm riding a bike in a rough circular path, which is making angle theta with horizontal. Okay, so let's consider a bike. Now it is moving in a path, circular path, as we discussed earlier. It is a circular path if we look from the top or from the sky. But now I'm not going to draw that. But here, rather I will be drawing this view from back side. So this will be look like this. Okay, so this is making angle theta with horizontal. So this is horizontal line. Okay, good. Let's consider this angle theta. Okay, and then I'm going to mark the forces. Okay, so the normal reaction force, it is always perpendicular to the contact. So it's going to be like this. From here, normal reaction force perpendicular to the surface, and then I have to mark the weight from the center of gravity vertically downwards, and the friction. Now I don't know whether friction will be in this direction or in this direction, right? So let's assume that friction will be in downward direction. The bike is tends to slide upward direction, so that friction will be in this direction. Let's consider like that. Okay, and this is the R and G, and this is F. Okay, so here now I'm going to draw two lines, vertical and horizontal lines. But if we consider this NG, that is vertical, so I doesn't have to bother about that. It is vertical, but these are making some angle. So I'm going to draw two lines so that I can resolve it. Okay. So let's take those two lines to be like this. One is this and the other one is this. Okay. Going through this point. Okay. So at this point I draw two lines. One is vertical and one is horizontal. And then I'm going to do resolving of forces. Okay. So first I'm going to resolve the normal reaction force. So one is in this direction, and the other one will be in this direction. And the friction also will be in this direction. This will be in this direction, and the other one will be in downward direction. Okay. And let's write these components. So in order to write the values, we need to know the angles. This angle theta means this angle theta, right? Then this is a right angle, therefore this angle is going to be 90 minus theta. If that angle is 90 minus theta, then this angle will be theta. Okay, good. So this component is r cos theta. Altaf, you know about vector resolving, right?
Yeah.
Okay. So this component r cos theta and this component r sin theta. Sorry?
After theta, what is the 90 degrees?
This angle is theta, right? So this is perpendicular. No, the r is perpendicular to this surface. Therefore, this angle is 90. So therefore, this is going to be 90 minus theta. And again, this and this perpendicular. Therefore, this is going to be theta. Or else we can start from this way. So here theta. Therefore, this is 90 minus theta. Right. Therefore, this side is 90 minus theta. Therefore, becomes theta. Okay. Okay, so this component r cos theta, this component r sin theta, and here this is f sin theta, and this side we have f cos theta as well. Okay, and now here again we have to use the same formulas. What are the formulas? One is f equals ma, and then considering the vertical equilibrium. Now this bike is moving in a circular path, therefore I can use f equals ma toward the center. So center is somewhere here, right, towards O, for the bike and the man. Right. So if you consider the force now in the horizontal direction, now we have in this direction we have r sin theta plus f cos theta also there, no? F cos theta, this should be equals to m centripetal acceleration, which is v squared over r. So r is the radius of the circular path. Are you clear to this point? Hello, can you hear me?
Yes, sir.
Okay, did you understand this formula?
I'm looking at it.
I can't hear you again.
The right side part I understood. The left side part.
Left side part, yeah. Left side part, now I'm considering this in the horizontal direction towards the center. Now, if I look at this from the above, it's a circular path. So the bike would be somewhere like here, no? Right? So bike is somewhere like here, and I'm applying towards the center, right? So center is somewhere here. To the center, I'm using f equals ma this direction, right? So in order to write down, I want to get the net force. Now this net force is, we have one component r sin theta is there, another component f cos theta is there in the horizontal direction to the left. We have both in the in this direction. Is that clear?
Yes.
Okay. So I take this formula as equation number 1, and then I'm going to consider the vertical equilibrium. Considering the vertical equilibrium, I have r cos theta, and r cos theta is upward, and then minus mg and minus f sin theta. Since it's equilibrium, net force should be equal to 0. In the vertical direction, it is in equilibrium. Therefore, according to Newton's first law, the net force in the vertical direction should be 0. Therefore, this gives me that r cos theta minus f sin theta equals mg. So this is equation number 2. So we have two equations, equation number 1 and 2, two unknown variables. So two unknown variables, they are r and f. So two unknown variables, two simultaneous equations. So now we can solve this, right? So therefore, to solve this, I'm going to equate the coefficient. So what I can do is, I can, I'm going to take equation number 2. I'm going to take equation number 2 and multiply that with sin theta divided by cos theta. That is actually theta. So I take this equation number 2 and multiplying with this, that will gives me that. So here r cos theta dividing by cos theta cancels off, so we get r sin theta. And then here minus f sine theta multiplied by sine theta sine squared theta, and then divided by cos theta will be there, is equals to mg sine theta divided by cos theta. Okay, so now if I consider equation 1 and 2, the components, the coefficients of this r and here r will be same, and also they are in the equal sign. Therefore, I can subtract equation 1 and 2. I take this as now equation number 2 dash. So I'm going to now subtract 1 minus 2 dash, right? So by doing that, I get here r sine theta plus f cos theta minus r sine theta, and minus this becomes, or as I write down like this, equation 1 minus equation 2, which is f sine squared theta divided by cos theta. This is equals to mv squared over r minus mg sine theta over cos theta. Okay, now let's simplify this. Then we have r sine theta plus f cos theta minus r sine theta. So here minus and minus, it becomes plus f sine square theta divided by cos theta is equals to mv squared over r minus mg sine theta over cos theta. So here r sine theta cancels off, and then we have f cos theta and here f. So here in this two term, f is common. I can take that out. So and then we have cos theta plus sine square theta divided by cos theta is equals to here mv squared over r minus mg sine theta divided by cos theta. Okay, and then let's simplify this further. Okay, I can multiply both side by cos theta, right? So if I multiply both side by cos theta, here we get cos squared theta plus multiplying with cos theta, here in numerator and denominator cancels off. It left that sine squared theta. I put here multiplying with cos theta. Okay. So okay, we'll have mv squared over r cos theta minus mg sine theta. Okay, and now what is this? Cos squared theta plus sine squared theta. It is equals to what? 1. Very good. So it is equals to 1. So we have f equals, here in this side, I'm going to take mg. I'm going to take mg to out. So mg, if I pull mg out, then I have here v squared over rg cos theta minus sine theta. Okay, so that is what we obtain for f. Okay. So this is f. We got this formula. Okay. Okay. Did you finish writing these simplifications?
No.
No. Okay. Can you finish it so that I can erase and use this space? Let me know once you're done.
Okay.
Don't just copy and paste. Just you go with the flow. You do the simplification by yourself. If you're stuck somewhere else, then you check with the my thing. Are you done?
No. This should be r sine
Where?
the diagram, the north.
Here you mean?
The, here in the document should be r sine theta.
This side you mean?
Yeah.
It is cos theta because this angle is theta. So it was the angle cos theta.
Sorry, I can't hear.
Now this angle is
The
theta.
angle is.
Yeah, this angle
The
is
angle.
theta.
Okay.
So this are cos theta. Therefore, this will be r sin theta.
Okay. The angle is there.
Okay.
I was thinking at the other end.
Even taking a screenshot is fine so that we can save time. You can fill your note later. No?
Okay. I don't
Okay.
can hit other.
Okay. So take a screenshot. Are you done? Okay, good.
Yeah.
Okay, so I'm going to erase this. Yeah. Okay. Now I have this f equals mg into this. I have obtained f. So now I can subject f in one of these formula to find r. So I'm going to choose equation number 1 or 2. So it's up to you. I'm choosing equation number 1. So in 1, I have r sine theta plus, instead of f, I can use this mg mg into v squared over rg cos theta minus sin theta. Okay, and this is f, and then we have cos theta here. Cos theta equals mv squared over r. So all we want to subject r. So let's keep here r sin theta and multiplying this in g and cos theta into the brackets. So we get v squared g cancels off in v squared over r cos squared theta in v squared over r. So here multiplying this in v squared over r, g cancels off, and cos theta cos squared theta minus we get mg sin theta cos theta equals mv squared over r. Okay, so keeping r this side, I'm going to take all the other terms to the other side. So r sin theta equals to mv squared over r minus mv squared over r cos squared theta plus mg sin theta cos theta. Okay, so now I can write r sin theta is equals to mv squared over r is common in these two terms. So mv squared over r, if I pull that out, 1 minus cos squared theta plus mg sin theta cos theta. So we have r sin theta equals to mv over r. What is 1 minus cos squared theta?
Sin square theta.
Sin squared theta, good. Sin squared theta plus mg sin theta cos theta. So we can see in this formula, all side we have sin theta terms. So sin theta, one of the sin theta cancels. So it gives that r equals to here again I'm going to pull mg out, the term mg out. If I pull that out, then I have here if I take mg out, so we have v squared over rg sin theta plus cos theta. Okay, so we have now r and f. So let me box this. Ouch. Okay, so okay, you may take a screenshot, because again I'm going to erase these simplifications. Okay.
No.
Are you done?
Yeah.
Okay, good. Give me a second. Okay, good. Now I will erase this part. Okay, so now we have f and r. So now what I'm going to do similarly, as we done earlier, I'm going to take this relation f over r. F over r, because we know f over r is always less than or equal to nu s, where nu s is the static friction coefficient of this road. Okay. Okay, so let's do the simplification here. So f is we have mg v squared over rg cos theta minus sin theta mg v squared over rg cos theta minus sin theta. This whole thing divided by this one r equals mg v squared over rg sin theta plus cos theta. So this thing is always less than or equal to nu. Nu is in order to keep easy for me to write, I just drop this s. Okay, so this is static friction coefficient nu. Okay. Okay, so here we can see mg cancels off, right? The term mg cancels off, and then I can do the cross multiplication, which gives me that v squared over rg cos theta minus sin theta is then equal to nu into v squared over rg sin theta plus cos theta, right? Okay, and then I multiply this nu into the brackets, right? So I multiply this nu into the brackets. So I have here multiply with nu and here nu. Okay. And I consider now this term v squared over rg, here also v squared over rg. So I take these two terms to one side. Okay. So we have here v squared over rg common, right? V squared over rg. Here this side cos theta. Now I brought this one also this direction, therefore this is becomes minus. So remaining is minus nu sin theta is less than or equal to nu cos theta plus minus sin theta taken to this side, it becomes plus sin theta. Okay. So here now I subject v squared or v or else v squared, I subject v squared is less than or equal to rg into mu cos theta plus sin theta, and the whole thing divided by cos theta minus sin theta. Okay. Okay, good. Now this is great. So we have derived conditions for this object to move in a circular path. So the velocity should be less than or equal to this particular value. Now, you know, when I read a book, something like related to science book, I really hate the author when he doesn't use the formulas, because some authors mention due to convenient of the layman or the reader, I have omitted the mathematical proof or derivations, something like that, formulas. So I really hate that author because the equations can tell us a lot of things, right? Like this contains informations of paragraphs, right? So this saves time because I am a lazy person to read paragraphs. So if there's an equation formula, so that I can understand so many things regarding that situation, right? So now let's analyze these three formulas. Okay. Okay, you may take another screenshot here. So we have obtained f, and here r, and here v squared. The v squared should be less than or equal to this particular value. Now first I'm going to analyze this f and r. Now if you consider here, now in f we have here minus sign, right? But in R, we have only a plus sign here. Now, what if this means, right? Now, this means, I'll explain that here. For that, I want to have space, so I will erase these things as well. Yeah. I hope you have took a screenshot, aren't you?
Yeah.
Okay, so I'll erase this one. These two steps. Okay, so now we can see if now f is greater than 0, right? If friction is greater than 0, then I can write mg into v squared over rg cos theta minus sin theta is greater than 0, right? Greater than 0 means it's a positive value, right? Okay, so here mg is a product, so I can say mg is not equal to 0. Since mg is not equal to 0, this term should be equal to 0. Sorry, we are talking about greater than 0, no? So since mg, this term, weight is a positive number, is greater than 0, this term also should be greater than 0. Then only the product will be greater than 0, no? That is,
Yeah.
okay, good. So that means v squared over rg cos theta minus sin theta should be greater than 0. Therefore, I can write v squared over rg cos theta should be greater than sin theta. Dividing both sides by cos theta, so we get v squared over rg should be greater than sin theta divided by cos theta, we get tan theta, right? Therefore, I can write v squared is greater than rg tan theta. Okay. Now we know this one moving in a circular path means there R should have some value. For example, like 100 meter radius, and g we know it is 10, and theta. So theta is now therefore v squared, the max v squared is something varying with theta, right? Now if theta is some like angle 60 degrees, so or 45, so tan 45 is 1. Suppose let's say theta equals 1, then we will get here v squared is greater than v squared is greater than v squared should be greater than r is 100 into 10 into 1, so v squared should be greater than for convenient I take this radius to be 10 meter. Okay, so it's easy for us to explain. So I take that to be 10 meter, or let's say 10 meter. Okay, so here it is 10. So 10 into 10 into 1, which is 100. Therefore, v squared should be greater than, v should be greater than 10 ms minus 1. Now, what this does? Now, if v is greater than this, f becomes larger. If v is larger than 10 ms minus 1, f is greater than 0. Suppose if v is, that means the tangential speed is less than 10 ms minus 1. What happens? Can you tell me? F becomes? F becomes a negative number, no? Can you understand that? Because here this is positive if this is greater than 0, and this is true when v squared is greater than this. So as an example, we consider this r is to be 10, g is 10, theta is 45 degrees, sorry, 45 degrees,
Okay.
so that tan 45 is 1. So we can see that if f is greater than 0, then v is greater than 0. Or otherwise, we can say if v is greater than 10 ms minus 1, f is greater than 0, right? Now,
Yeah.
suppose if is less than 10 ms 1 minus 1, then it
Minus.
becomes
Minus.
greater than 0. That means f is negative value. F is negative value. So in vectors, negative means what? Direction?
Change.
Direction changes. Exactly. Okay, now I'll explain thoroughly why it happens. Right? So the direction will change something to the force direction. Friction will change to this direction. I'm going to explain this one. Now, suppose now, let's say you are keeping a box. Okay. Let us say you are keeping a box on this one. Okay. Can I rotate this? No, say it. It's not.
It's fine.
Okay, okay. I will draw that. Let us say we just place a box. Now, if I place a box, what happens is tends to fall this direction, no? Slides into this direction, so that friction will be this direction. Similarly, if I just keep this bike on this, the bike tends to slide this direction, therefore force will be this direction. Now, but we are giving a force so that it will counterbalance. So now we can see now the direction of this force is depends on this velocity, right? Is that it is clear? The direction of the force is depends on this velocity, because if this term is greater than this term, then it is a positive value. F is positive. Otherwise, if this term is smaller than sine theta, then it's a negative, or else we get the same here. F is greater than 0 if v squared over rg cos theta minus sine theta is greater than 0, or simply we can say f is greater than 0 when v squared is greater than rg tan theta, right?
Okay.
Otherwise, the direction of the f changes if the velocity is reduced. Let's say, for example, 0 or 1 ms minus 1. In that case, what happens? This bike tends to slide this direction so that the friction force will be in upward direction. Is that clear?
Yeah.
Now that's very good. And also now if I consider the r, so r doesn't, the direction of r doesn't depends on v squared. That's why here whole term is positive. Whatever the value of v, it is always going to be in upward direction. It's never going to be changed, no? Right?
Yeah.
Okay, so good. And also now we can see, in order to maintain this bike in a circular motion, the v squared should be greater than this value, right? Should be greater than this value. Now, in the previous case, we write down that v squared is greater than, less than or equal to. So v squared should be here. This one less than or equal to this particular value. In the previous case, when the road is flat, it is only G nu, no? Right? But now here, if I consider this term, right? If I consider this term, this is actually, I can say that this is, if I write down Rg into nu cos theta plus sin theta divided by cos theta minus sin theta. This term is greater than Rg nu. Is that clear? It is not appearing, but we can do some simplifications to show that. Wait, I will rewrite this. Now,
Sir, can we continue with the next class because I told you that I have to go at 12.
Yeah, okay. Okay, fine. So yeah, we are, let's consider we have like 15 minutes remaining, no?
Okay, let's do it next class, inshallah.
Because 15 minutes means because we started at 10:30 and then you and both we take about 5 to 6 minutes, no? So there are 15 minutes left, so we will cover that in the next class. Okay.
Okay, sir, inshallah.
Okay, and one last thing I'll ask you this here new. Okay, one last thing, because I can't again and write all these things. So if this is the last thing, okay, just take a minute. Okay, so here new is smaller than new cos theta plus sin theta, okay, divided by, so here put a bracket, cos theta minus sin theta. Can you understand this? Because this is something, let's say 2 plus 3, or sorry, I take 3 plus 2. This is something like 3 plus 2 divided by 3 minus 2, no? 3 minus 2, which is means this number is greater than 1. So this product, this value is greater than 1, right? Is greater than 1. So, okay. So it is greater than 1 means multiplying a number greater than 1, taking 5, multiplying with a number greater than that. So it gives a large value, no?
Larger than 1.
Yeah, it gives a larger than that. So that is why now it is very clear. Now it is in practical understanding. Now this is very stable compared to that, because here the new is greater, no?
Yeah.
So that's why you may have seen that in the formula races and like bike races, when they take a win, it's like not horizontal, but it's slightly tilt like this. No? The road is, so here there's rails are there and the people are looking this side, audience will be there. The road is like this, no, in formula races and in the bike races. Have you seen that?
The road is tilt.
Yeah, road is tilt. That's because so that it gives extra stability. Right?
Okay.
So we can increase the speed greater than this particular value, because we can see here this larger value here. Okay, so good. With all that understanding, let's finish from here, and then yeah, so you can leave. See you on next. Okay, let's talk about that. We can discuss that in the WhatsApp. Okay. Okay, then take care.